Okay everybody, now we're going to talk about section 1.8, and this is the only section we'll be covering this week. The other thing you'll be responsible for is getting ready for the chapter 1 exam through the chapter 1 review. But in section 1.8 we're going to cover a really important topic, and you may or may have not have seen this before, but we're going to be talking about exponents and order of operations. The order of operations in particular is really going to be important because if you use the wrong order of operations in future problems in algebra and pretty much for the rest of your college career, it's going to give you an incorrect answer. It's really important to understand, know, and execute the order of operations just as they're defined. So hopefully you guys are taking some good notes or have these notes handy so it can guide you through the homework. But first off, we're going to just talk about exponents and what that means. So an exponent is going to, here they give you a generic example of, we have what's called a number b to the n power. So we're used to seeing something maybe like 2 and then a little 2 to the top. That means 2 squared, or 2 to the 2 power. In this case we have b to the n power. And this n power, all that means is it's a shorthand way of writing b times b times b times b. Let's say n was 7. It's a short way of saying b times b times b times 7 times. So it just shortens things up for us. So it's really just a nomenclature or a shortcut for writing things. In math you'll find that we like to use shortcuts a lot because it can get pretty time consuming and messy to write so many letters out each individual time. And the way we read this is b to the n is read the nth power of b, or b to the nth power. Let's go ahead and see what that really looks like with real numbers. So here we have a term 3x squared. We say anytime we see a 2 we call it squared. When we see a 3 we say cubed. When we say 4 we say to the 4th. You can also say to the 2nd or to the 3rd, but it's kind of optional. So here we have 3x squared plus 7x squared. There's some rules whenever we have variables with exponents. The exponent, the variable of course has to be the same x and an x, but now there's an additional rule when we combine things to get like terms, that the exponent power also has to be identical. So if this is 3x squared, we can only add this second term if this is also an x squared. So now we just use the same rules like we did before when we added like terms, and since the x squareds are both here on the first and second term, we just add the coefficients, and we know 3 plus 7 is equal to 10, and we keep our variable x squared. So here we have one, it's 5x to the 3rd, or 5x cubed, plus 4x squared. Remember, the rule is we have to have the same variable as well as the same power. Well, so here we have x to the 3 power, to the 3rd power, and here we have x to the 2nd power. Since the powers don't match, since they're not the same, we cannot simplify this any further, so our final answer is just 5x to the 3rd plus 4x squared. So you're going to find, we call this a polynomial. We'll talk about that much later. But you'll find in equations that sometimes we have what seems like a lot of terms, but we have to be careful when we combine them and simplify them. So again, we just apply the rule that not only do the variables have to be the same, but we can only combine terms that have the same power of that same variable. So here we start off with the 3x to the 4th. So what a good trick to do is kind of circle this and go through and see if we have any other x to the 4th. And here we do here a plus 5x to the 4th. So you can see what we did here is we grouped them together, the 3x to the 4th plus the 5x to the 4th, and we grouped them with the parentheses using our associative property. Then we go to the next term, it's a 2x squared. Now we look for any other x squareds. So we have a negative or minus x squared here. Now we go to combine those two terms, the 2x squared minus x squared, in another set of parentheses using our associative property. And now we can just simplify the two smaller parentheses to get 8x to the 4th, which is 3 plus 5, and that's 8. And we know the variable with the power stays the same. And here we have 2x squared minus x squared. That's just going to be a positive x squared, or 1, We don't have to put the 1, but we should know that it's there. So now order of operations. There's some rules that hopefully you guys take note of and are able to use, because they're real helpful, and it's really going to be the only way you're going to get the right answer. So the first thing you always have to do is perform all operations within grouping symbols, and a grouping symbol is a parentheses or a bracket or an absolute value sign. You always have to start with the innermost and work your way out. Number 2, you have to evaluate all exponential expressions, so evaluate all your exponents. The third thing you do is do all the multiplication and division in the order they occur, working from left to right. And then the fourth thing you need to do is do all the subtraction, addition and subtraction in the order they occur from left to right. So here's some examples of order of operation. Here we have 9 plus 2 times 3. Well, order of operation tells us that here we have an addition and a multiplication. Order of operation tells us multiplication comes before addition, so we have to go ahead and do the multiplication with these two numbers first. So 2 times 3 is 6. So now we get 9 plus 6. Now we can do our addition. 9 plus 6 is 15. If we had done it differently, if we had done the addition first, we would have got 9 plus 2, which would have been 11. 11 times 3 is 33. That you can see that does not equal to 15, so we would have got a wrong answer if we would have done the addition first. Next, they ask us to simplify this expression. Well, the first thing we do is we see the exponents come before any addition, subtraction, or division, so we evaluate the exponent first. 2 to the third power is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So we got 8 minus 15 divided by 5 minus 6. Now we go ahead and use our rules again, and we see that division comes before subtraction. So we go ahead and divide 15 divided by 5, and that equals 3. So here we got 8 minus 3 minus 6. Now we do our subtraction in the order it occurs. 8 minus 3 is 5. And now we have 5 minus 6, and that is equal to negative 1. And that is our answer. Here's another example using some grouping symbols. Grouping symbols we're using here are parentheses as well as brackets. So with our parentheses, I'm sorry, with our order of operations, we know we have to do the innermost first. So we have to look at this guy, and we see that innermost is actually the parentheses. So we have to do what's inside the parentheses first. So we look at all this, and 3 minus 7 is going to be negative 4. And here we get negative 4. Now we go ahead and have to do our multiplication inside here to keep working inside this next grouping set, because we know that multiplication comes before addition. So we multiply 2 times negative 4, we get negative 8. Now we have negative 8 plus 6 all times 5. We're going to combine these two in the brackets, and we get 5 times negative 2. And now we can go ahead and finally do our multiplication and finish the problem, and we get negative 10. So again, here's another example using order of operations. I'm going to go ahead and stop the video now because this one may take a while, and I don't want to cut it in half. So maybe go try a couple of problems, a couple more simple problems, and come back and watch this one and see if it helps out.